Hello students, in this lecture we will solve some more problems on equilibrium of beams. Already in previous lecture we have covered some 3 problems. Before that one in equilibrium, what we have done, we discussed about theory part of equilibrium. So mostly in support reaction of beams, you will get some hinge support, roller support, sometimes you may get what? Fixed supports also. We will solve some 2 to 3 problems in this lecture. Okay. The first problem what I will start here is from May 2016 exam. This is from May 2016 exam, right? This is our first problem. In this lecture this is first problem. What is given? Length of beam is given as 6 plus 2, 8, 8 plus 6. 8 plus 6 means 14 meter long beam. This is 14 meter long beam. Okay. 6233. This is 6 meter, 6 meter, 2 meter, 3 meter, 3 meter. First we will always properly represent length, means all distances which are very important when we will take moments, right? So this one is a given beam. Length what is given is divided in 4 parts. This one is 6 meter, next is 2 meter, next is 3 meter and 3 meter. 6, 2, 3, 3. Okay, 6, 2, 3, 3. What is given here is support. You know this support is called as what? Hinge support. But at this end a roller is represented by different way. One single roller and then some horizontal plane. So this is nothing but what? Roller support. Sometimes it is represented like this and then 2 to 3 circles means rollers may be represented. So total length of beam and then 2 support. Name of this end support is what? Name of this support is E. Name of this support is E. What loads are given I will represent here. First in 6 meter what is given. So this one is UVL is given, which is acting in downward direction. This one is UVL. And magnitude of this load what is given is 20 newtons per meter. Name of this point what is given is what? B. Name of this point is given as C. Name of this point is what? D. At point C what is acting? One point load inclined at an angle of 60 degree. Inclined at an angle of 60 degree. Magnitude of this load is how much? It is 50 Newton. This is 50 Newton. And at point D one couple is acting, that is clockwise, and this is 100 Newton meter. Let me check all loads properly represented or not. Yes, 20 Newton per meter, perfect. 50 Newton incline at what angle? 60 degree. 100 Newton meter clockwise, and supported is what? Roller support. Okay. What is the first step in solving any problem? We will draw free body diagram. So when we will draw free body diagram, basically we will not represent these supports. That means when we will solve any problem, what we will do, instead of support we will represent support reaction. Hinge support means how many reactions we will represent? 2 components of reaction. Means we will get RAX and RAY. Roller support, how many reactions? Only one reaction. In which direction? Perpendicular to contact surface. Contact surface is horizontal. That means reaction you will get in vertically upward direction. Name of end point is E. The name of reaction is RE. Okay. Now there is one UVL. One is point load, other one is couple. Whenever there is a distributed load, we will convert it into equivalent point load. So in 6 meter, where we will get equivalent of this UVL nearer to maximum load? How much distance? 1/3 of its span. Span means distance in which this load is acting. So span is 6 meter. That means from this end B, 1/3 of 6 if we will take, this distance comes out to be how much? 2 meter. And this distance is how much? 6 minus 2 means 4 meters. Magnitude of this load is what? Half. Base is what? 6, means L and W. WL by 2 comes out to be how much? 20 into 3, 60 Newton. So this one is your free body diagram. In FBD, what we'll do? Remove support, add support reactions. Next, any distributed load is given, we'll convert into equivalent point load. Now we'll apply equations of equilibrium. We'll select moment center such that moment of two unknowns becomes 0. At point A, if we take moment of Rx 0, moment of Ray 0. The moment of two unknowns becomes 0. That means applying moment equation, what is possible is what? Re. Once we'll get Re, then summation of Fx equal to 0 will apply, we'll get Rax. Summation of Fy equal to 0 will apply, we'll find out what? Ray. Now if we take moment at point A, and that is equal to 0, first equation, sum of moments about point A equal to 0, taking anti-clockwise moments positive. One by one we'll discuss moment of each force and we'll write each term. Moment about point A due to 60 Newton. So 60 Newton load is downward. How this bar will rotate due to 60 Newton? Clockwise, means minus 60 into force vertical, distance horizontal. How much? 4 meter. That means what we'll get? Minus 60 into 2, clockwise movement. Correct? Yes. Next, this 50 Newton what force is acting? Force is inclined. Direct movement is not possible. How will take moment of any inclined force? So here horizontal distance is available, so that will resolve in horizontal and vertical direction. Inclination with horizontal is 50, the vertical component 50 sin 60, horizontal component 50 cos 60. Okay, moment of horizontal component of 50 cos 60 about point A is 0, because line of action of this force passes through point A. We'll get moment of only vertical component. What is the direction? Force downward, bar horizontal. How this will rotate? Say AC part, how this will rotate? Clockwise. Minus 50 sin 60, force vertical. What distance? Horizontal. How much? 8. That means minus 50 sin 60 into what distance? 6 plus 2, 8. See here we have made mistake here. This is not 2 meter, 60 into, you are taking moment at A. What is the distance? 4 meter, right? So this distance is what? 4. 60 into 4 minus 50 sin 60 into 8. Then there is a couple clockwise minus 100. Clockwise means negative. Moment of Re, if you take about A, it is anti-clockwise. So Re into what distance? 8 plus 6. 8 plus 6 means 14. Plus Re into 8 plus 6, how much? 14, right? Equal to what? 0. Clear moment equation. Force into perpendicular distance. Simple problem. Forces are mostly what? Vertical. Perpendicular distance is horizontal. Moment of horizontal component of 50 Newton is what? 0, because line of action of this force passes through point A. So what will get here? Re equal to, how much Re will get here? It is 49 Newton. 49 Newton. You calculate yourself and check, right? You must get same answer. Now other reaction. Re you are getting. Summation of Fx equal to 0 will apply. That means summation of all forces along x-axis, assuming what? Rightward forces positive. Now concentrate on only horizontal forces. One is Rax. Rightward means what? Positive, plus Rax. Plus Rax. Component of 50 is in leftward direction. 50 cos 60. This is negative, minus 50 cos 60 equal to what? 0. That means what will get here? We'll get some Rax. Cos 60 half hota hai, that means Rx comes out to be what? 25 Newton. Again answer is positive, that means what? Assumed direction of Rx is correct. What is assumed direction of Rx? Rightward. Answer positive, that means direction of Rx is what? Rightward. Next, summation of Fy equal to 0, assuming vertically upward force is positive, what will get here? Ray upward positive. One Re upward means positive plus Re, upward forces are taken first one. Ray upward, Re upward, both positive. Now in downward direction what will get? 60, component of 50, 50 sin 60 downward, only two forces in downward direction means what? Minus 60 minus 50 sin 60 equal to what? 0. We'll substitute here what? Value of Re, what will get? Ray. Ray answer comes out to be 54.3 Newton. And this answer is positive, that means again assumed direction is correct. What is assumed direction? Assumed direction of Ray upward. Answer positive means what? Ray vertically upward. Whenever we will get some two components, find out resultant reaction. The resultant reaction will get in first quadrant because this is rightward, this is upward. How will get? Ra square root of Rx square plus Ray square, and inclination of reaction is what? Tan inverse of Ray upon Rx. Clear? Yes. Now we'll solve next problem from university exam, that is from May 2018. May 2018. Mostly these problems are asked for 8 marks. Okay. Again, in May 18 problem for 8 marks, what we have covered is from May 16 exam. Now in this problem what is given? Slightly more distributed loads are given in this May 18 problem. That means this is our second problem of our lecture. Okay, what is given in this problem? Total length of beam is very important. 2 plus 1 3, 3 plus 1 4, 4 plus 3 7 meter. So let me represent here 7 meters. Say this one is what? 7 meter long beam. Okay, how it is divided? 1 2 1, 1 meter, 2 meter, then 1 meter, but 1 meter is again divided in two parts. 1 2 3 4. These distances are 1 meter, 1 minute, yes, 1 meter, 2 meter, 1 meter, 2 meter, 0.5 meter, 0.5 meter. Okay, that means 2 plus 1 plus 1, 4 meter. Remaining part is what? This is 3 meter long. Represent next distance as what? A 3 meter. Okay. Now what supports are given? So here what supports are given? That one is at this point. This is your A, and here what support is given is hinge. It is not at end A. Normally one support is at end A, other one is at end B. You will get in most of the problems. Sometimes you will get position of support at different location. Other support जो है, this one is at other end B, and you know this is which type of support? So this is a roller support. Now in last 3 meter combined load is given 10, 20, this is 10, this is 20, and this is inclined. That means this one is what? This is a combined load 10, 20, and direction of force vertically downward. Forces are acting in downward direction. Unit is what? In kilonewton. So this is kilonewton per meter, 20 kilonewton per meter. This is in last 3 meter. Then what is given in this part? What load is given? It is again UVL and UVL. Right? That means slightly more number of distributed loads are given in this problem. Magnitude of load, which is maximum at this point A, support A, is how much? It is 10 kilonewton per meter. 10 kilonewton per meter. Next, one more point, there is some point load is given, that is how much? 12 kilonewton incline at 30 degree. This is 12 kilonewton incline at what angle? 30 degree. Any couple वगैरह given? No, nothing is given. What is asking problem? Find support reactions at A and B, right? Whenever any support is given, will represent what? Support reactions. Support at A, which is not at left end, 1 meter from left end, here hinge is given, means what will do? Will represent what? Reactions for hinge. How many reactions will get for hinge? 2 reactions. One is what? Vertical component, other one is what? Horizontal component. Support is A, that means this is RAY and this is RAX. Supported with roller support. So at roller support, what will get? Only one reaction, perpendicular to contact surface. That means this is what? RB. Clear? All you are done? Yes. Now what we'll do? We'll convert these distributed loads into equivalent point loads. So how many distributed loads are there? First, there is one UVL in 1 meter. Next, in 2 meter there is a UVL, and in this 3 meter there is a combined load, combination of UDL and UVL. Step by step now we'll convert these loads into equivalent point load. First, in this 1 meter what UVL is given, equivalent will get where? 1/3 of its span, means 1/3 of 1 meter. From where? From maximum load. Maximum load is at A. That means now equivalent load of this UVL, if will represent at 1/3. 1/3 of 1 meter, how much? 1/3 of 1 meter is what? 0.33 meter. Okay. Magnitude of load WL by 2 means half W10. L how much? 1. That means what is the magnitude? 10 by 2. 5 kilonewton. Okay. This load is 5 kilonewton. Clear? Next, in 2 meter, what UVL is given? It is maximum at A. From maximum load, equivalent load will get where? 1/3 of its span. 1/3 of 2 meter means how much? Means 2 by 3. 2 by 3 means 0.6666 hai na? So we'll take 0.67 meters. Magnitude of load WL by 2 means 10 into L2 divided by 2 means comes out to be 2 cancel 10 kilonewton. Clear? Yes. That means not difficult. But here this is a combined load. When your combined load is given, what we'll do? We'll divide in 2 parts. Lower part is UDL, upper part is UVL. For this UDL, its intensity or magnitude of UDL is 10. Total is 20. That means for UVL, load is not 20, it is 10, because lower part 10 is for 10 kilonewton per meter is for UDL and upper part is of UVL. Now for this UDL, equivalent where will get? At its center of 3 meter. Center of 3 means what will do? 1.5 meter, right? Center of 5, center of 3, 1.5 meter. 1.5. Magnitude of load W into L. W is what? 10. L is what? 3. That means this is 10 into 3. That means this load is how much? 30 kilonewton. Correct? UVL is remaining now. Equivalent of UVL where will get? 1/3 from maximum load. Maximum load is at B. From B 1/3. From B 1/3. 1/3 of what? 3. 1/3 of 3 is what? 1 meter. So total 3, 1.51. That means automatically you will get this distance as what? 0.5 meter. Okay. Magnitude of load WL by 2, 20 W. L is what? 3. Divided by 2 means 10 into 3. No, this is not 20. This is what? This is a 10, right? This is 10. 10 into 3. 10 W. L is what? 330 divided by 2 means how much? 5 into 3. How much? 15 kilonewton. Correct? That means what we have done, we have drawn complete free body diagram, then we converted distributed loads into point loads. Now how we will find out these unknowns, means reactions, and Rx, Ry and Rb. For that one, we will select moment center such that moment of two unknowns becomes 0, moment of two unknowns, which is possible at A. If we will take moment at A, you will get moment of first 5 kilonewton. 5 kilonewton on left side. The moment of 5 kilonewton not about free end, about point A is what? Anti-clockwise. Now see here I will write equation. Sum of moments about point A equal to 0, taking anti-clockwise moments positive. This 5 kilonewton is on left side of A. Means this one is A. Force is on this side. How this will rotate? Anti-clockwise, right? Anti-clockwise. So as this will rotate anti-clockwise, I will write plus magnitude of force 5. Distance is what? 0.33. Okay. First term clear. Moment part is very, very important. Next, about point A, if you take moment of 10, that means this one is say point A. Force is on right side. How this bar will rotate? Clockwise. Minus 10 into 0.67. 10 into 0.67. Clear? Yes. After this, moment of 12 kilonewton if you want to take, what we'll do? We'll resolve. That means, vertical and horizontal component. Vertical component becomes what? Angle is with horizontal. Vertical component is what? Sine. 12 sine 30. Now as this is 12 sine 30, moment of 12 sine 30 about is what again? Clockwise. Distance 2 and 0.5 means 2.5. Moment of horizontal component of 12 is 0 because line of action of horizontal component of 12 kilonewton is what? Passes through point A. Whenever line of action of any force passes through moment center, moment is what? 0. Moment of horizontal component 0. Moment of vertical component about A is what? Clockwise. Minus 12 sine 30. Minus 12 sine 30. What distance will get? 0.5 and 2.5 meter. Okay. After this, next is 30 kilonewton. Again, moment is what? Clockwise, means what will write? 30 into distance 1.5 and 1, 2.5. 2.5 and 2 means 4.5, right? 4.5. Moment of 15 kilonewton about A, again clockwise, means minus 15 into what distance? Additional 0.5 means what? 5 meter, correct? Just check. 2 plus 1, 3. 3 plus this one, 2, 5. Moment of RB about A. Horizontal bar. Apply force upward. How this will rotate? Anti-clockwise means plus RB into what distance? 2 plus 1, 3. 3 plus 3, 6. And equal to what? 0. That means, now if you calculate this RB comes out to be what? 38.34. 38.34 unit kilonewton. Answer positive means what? Assumed direction of reaction is what? Correct. What is assumed direction? Upward. What answer you are getting is what? Positive answer means upward reaction. Clear? Now next, summation of Fx equal to 0, assuming upward force is positive. Along x-axis check what are the forces. One is Rx, other one is component of 12 leftward, means minus 12 cos 30 and plus Rax. Plus Rax minus 12 cos 30 equal to what? 0. So what will get here? Rax equal to, again answer is what? Positive, and what will get? 10.39. If we calculate this one, 10.39 kilonewton, and assume direction is correct, means direction of reaction is what? Rightward. Summation of Fy equal to 0 if you will apply. Now concentrate only on vertical forces. What are the vertical forces? Ray. Next is Rb, upward. Ray and Rb upward. Ray and Rb upward. 5 downward, 10 downward. Minus 5 minus 10. Minus 5 minus 10 downward, negative. 12 sin 30 downward minus 12 sin 30, sin 30 half hota hai means you can take 6, 30 downward, 15 downward, minus 30 minus 15 equal to 0. Just check all the forces. RAY upward, yes. RB upward, yes, positive. Minus 5, yes. Minus 10, yes. Minus 12 sin 30, yes. Minus 30 minus 15, RB already written, equal to 0. That means here if you substitute RB value, you must get what? RAY. Calculate RAY. RAY comes out to be 27.67. 27.67 kilonewton. Answer positive means assumed direction is correct. What is assumed direction of RAY? Upward. Clear? Important is what? Conversion of all distributed loads into equivalent point loads is important. How to convert all distributed loads into equivalent point load? We'll solve one more problem from recent university exam, that is May 2019. Next problem is from May 2019. May 2019. Ask for how many marks? Again 8 marks. Chalo. Ready? All you are done? Yes. That means this is our third problem in this lecture. In third problem, again first we will draw given figure. So in this problem, what is given? One horizontal bar and there is an extension in vertical direction, means you can say bent bar. So just here, what is given? Horizontal is given as 6 plus 2, 8 meter. 6 plus 2, 8 meter. This one is 6 meter. This is 6. I will write here. This one is a 6 meter. Next, this one is a 2 meter. And there is a vertical portion of again bar like this. Okay, this one dimension 2 meter and this vertical is what? 2 meter. In this 6 meter, what is given? There is one UVL which is something like this. 1 minute. It is up to this location. So this one is what? This is a UVL. UVL is acting in downward direction. What is the magnitude of UVL at left end? Left end, what is the name given? That is A. Name of left end is what? A. Then magnitude of load is how much? 4 kilonewton per meter. Name of this point is what? B. Name of this point is C. Name of this point is D. At B there is one couple acting. How much? 10 kilonewton meter. This is a 10 kilonewton meter. Not per meter. Kilonewton meter. Na couple. At D one force is acting which is inclined. Inclined at what angle given? 40 degree and 20 kilonewton. Okay. There is one point load on left side of B. Additional. How much? 10 kilonewton point load. This is 10 kilonewton point load. At what distance? 1.5 meter from B. Okay. Now what support is given at A is something like this. This one is a support at A. This is which support? Roller. And at B one more support is given, and support is something like this. This is a support at B. This is which support? Hinge support. This given problem. 6 meter, 2 meter, 2 meter. One inclined load, one point load, one couple, one UVL. First step is what in solving any problem? We'll draw free body diagram. That means we'll remove supports and we'll represent support reaction. At A there is roller support. Whenever there is a roller support, how many reactions will get here? Only one reaction perpendicular to contact surface. That means here what will represent? RA. At B there is a hinge support. Hinge support means what? Two components of reaction. Number of problems we have solved on this one. So horizontal and vertical, this is RBX horizontal component, this is RBY vertical component. This is our first part. Next what we have to do, distributed load is given. We'll convert this distributed load into equivalent point load. So equivalent of UVL is where 1/3 of its span from maximum load. Maximum load is where? At A. So from A 1/3. 1/3 of what? 6 means how much? 2 meter. So we'll represent one equivalent load at what distance? 2 meter from A. Magnitude of load WL by 2. W4 L6 divided by 2 means what? 6 into 2. How much? 12 kilonewton. Correct na? 4 and 6 divided by 2. 6 into 2, 12. This is what? 10. ये आपका 10. This is what? 20. First class. Next step is what? Apply equations of equilibrium and find out unknowns. So what is possible here? See here, moment center. Huh? As RBX and RBY passing through B, if you take moment at B, it is perfect. No doubt. Even instead of B, if you take moment at A, is it correct or wrong? It is correct. Why it is correct? If you take moment at A, moment of R is 0. Even line of action of RBX passes through A. That means what? Moment of RBX 0, moment of R is 0. So if you take moment at A, you will get only one unknown in equation, that is what? RBY. That means you can take moment at A, you will get RBY, then summation of Fy equal to 0, we will find out what? RBY, and then summation of Fx equal to 0, we will find out what? RBX. So it's not compulsory you can take moment at B, you can take moment at A also, right? Now you can take moment at A or B. Say I will take moment at B. Sum of moments about point B equal to 0, taking anti-clockwise moments positive. Chalo, at B you are taking moment. So moment of first RA, moment of RA. So hold AB bar, hold it at B, apply force in upward direction. Moment of RA is what? Clockwise. Minus RA. Minus RA into what distance? Vertical force, horizontal distance. How much? 6 meter. Moment of 12 kilonewton about B. Hold it at B. Force where? Left side, downward. How pen will rotate? Anti-clockwise. Hold it here. 12 kilonewton. Anti-clockwise. Plus 12 into what distance? This is 2 meter. This is 6 meter. Means how much distance? 4 meter. Same thing. Moment of 10 about B. Again anti-clockwise. Plus 10 into what distance? 1.5. Okay. 10 kilonewton meter clockwise couple. Clockwise means minus 10. Now, moment of 20 if we will take about B, directly moment is not possible. What we will do? I will resolve. Horizontal component, vertical component. This is what? 20 cos 40. This is what? 20 sin 40. Two components. So moment of horizontal component, then as a bent bar, hold it at B, apply force leftward. How this bar will rotate? Anti-clockwise. Even due to 20 sin 30 also it rotates in anti-clockwise direction about B. That means moment of this 20 cos 40 is what? Anti-clockwise. 20 cos 40. Now what is the distance? Moment center is B, force horizontal, perpendicular distance vertical. What is the distance here? 2. Moment of vertical component again anti-clockwise, 20 sin 40. What is the distance? Force vertical, distance horizontal. This is line of action of force, this is moment center. What is the distance here? 2 meter equal to what? 0. What will get here? RA. Write down and calculate. How much RA will get? Just check. 18.22 kilonewton, and this one is positive. Answer means assumed direction is correct. 18.22. Once you will get RA, now summation of Fx and Fy. Summation of Fx equal to 0, assuming rightward force is positive. What will get? Rx, RBX, RBX, rightward. Rightward means what? Positive. Any other force, so this one component. Minus 20 cos 40. minus 20 cos 40 equal to what? 0. So what will get here? Rbx equal to 20 cos 40. Just calculate how much you will get. 15.32. 15.32 kilonewton. Answer positive, means assumed direction is correct. Next, what we'll do? We'll apply equation along y-axis, summation of Fy equal to 0. What are the forces in vertical direction? Ra upward, Rby upward. Means I will write positive. Ra plus Rby. Two forces, Ra and Rby. Minus 12 minus 10. And component of 20 upward plus 20 sin 40. Upward means positive, equal to what? 0. Now, you know Rby. No, Rby, Ra is known. Ra will substitute here. What will find out? Rby. But Rby answer is not positive. It is negative. Rby is what? Negative, and comes out to be 9.08 kilonewton minus 9.08 kilonewton. As you are getting negative answer, what it represents? Assumed direction is wrong. What is assumed direction of Rby? Upward. That means what is the correct direction? Downward. Clear? From Rbx and Rby, you can decide what is the quadrant. A rightward, this is downward. Rightward and downward means fourth quadrant. Magnitude of Rb is given by what? Square root of Rbx square plus Rby square. Theta will find out tan inverse of Rby upon Rbx. You can find out later on from Rbx and Rby resultant reaction at behind its inclination. Okay, clear? Yes. So thank you very much. We'll stop here now. Okay, thank you. Bye bye.